why do we want to get back to the moon, you may ask? Well, maybe for a new vacation spot, that would be nice. And it's actually not as funny as you could get. It's maybe someday we'll be able to go on vacation on the moon. But also for the science. Now, we've had the International Space Station launch a few decades ago, and now it's working very well, but we want to take the next step. And the next step is the moon and onwards to Mars. But it's going to be a long way to the moon surface. So we're going to start in 2024, and we're planning on sending, hopefully this time, a man and a woman to the moon surface. And then being able to establish an outpost that will be a very, very nice place to do experiments and prepare for a trip to Mars. And there's a concept of a moon village. The moon village is something that is planned to be established on the moon surface. At the beginning, it was planned by the European Space Agency, so ESA in short. And they are planning to have this outpost, as I mentioned, with people coming for scientific exploration, scientific experiments, maybe also space tourism, and plan the people, the astronauts, to go to Mars afterwards. But this is such a great adventure. How can we get the public involved in this adventure? So this is a question that we at Space at Your Service asked. How can we get the students and space enthusiasts involved, but also you, the one looking at us right now, how can the general public get involved in this great endeavor? So you can do outreach events like we're doing right now, and well, just making sure you are aware of what's happening. But we can also do student programs, such as the Luna program that was launched by the Swiss Space Center. I don't know if you've heard about it, but basically students which are developing technologies that will be useful for the moon, but also for Earth. And I think this is a very important topic. Don't forget that everything we do in space has also advantages on Earth. There's this great website called NASA Home. Really, I recommend you check this out. It's a website where you can go in your house and explore, and you can see the different technologies that were developed thanks to space exploration. So if it wasn't for space exploration, you wouldn't have coffee the way we do today. Babies wouldn't have the same milk as they're drinking today. So space is just not about exploring, it's also about living sustainably on Earth. Concerning the general public, so as I mentioned, you should get involved in this adventure, and you can do so also through social media and immersive activities. At Space at Your Service, we've developed an escape game, so an immersive game when you can be in the lunar base and try to resolve some issues as if you were on the moon surface. So we really try to have you involved in the adventure with us. And the very subject of my presentation is space analog missions. Space analog missions, this is very complicated worlds, but to be very clear, it's just space missions, but remaining on Earth. So basically, we are simulating how life will be on the moon or Mars, but staying on the Earth's surface, but going into more extreme environments. And this is the goal of Asclepios. Asclepios is kind of hard to pronounce. For those who don't know, Asclepios is the god of medicine and the son of Apollo. So this is why we chose this as a symbolism of our mission. And we like to introduce this as a do-it-yourself space mission because we made it from scratch. So the innovation in our project is that it was completely made by and for students, because there are about, let's say, 10 analog missions worldwide, but they're usually run by NASA, by the European Space Agencies, and they're not very accessible to all us students. So this is why we created this project, which is mainly directed by EPFL students. And we really have this educational and scientific purpose that differ from maybe other missions. So you might say, wow, that sounds like a very big project. There must be lots of challenges, and there are. The coronavirus was a good one because our mission was supposed to take place in April 2019. So as you all know, it didn't take place, but we are facing many other challenges. So if you want to plan your own space mission, what do you need to think about? Well, 5 things: where, who, when, what, how. main things you have to ask yourself when you create any project whatsoever. Where? Well, in our case, we are going into a lava tube environment. So on the moon, there's what we call lava tubes, and it would be a great place to establish a moon base. Why? Because if you go into lava tubes, you can be protected from radiation coming from the sun and the earth. So it would be a good place, let's say, to tackle already existing challenging of living on the moon. And in our analog mission, so we're staying on Earth, so not going up in the moon. So we looked for networks of tunnels here in Switzerland, and we found a location, the Grimsel test site, in the Swiss Alps in the Bern canton. And our astronauts, analog astronauts, will be staying there. So it's kind of extreme. It's 13 degrees, complete darkness. What I mean by darkness is you don't have any sense of sunlight. There's no windows, right? You're underground. And there's nothing but tunnels. So you have to think about how they're going to sleep, how are they going to go to the toilet, how are they going to wash themselves, there's no shower, etc. So you start from scratch and you have to design a moon base from that. This is one of the main challenges. Then when? How long? Well, in our scenario, we're going up to the moon for the exploration of those lava tubes. So we are in the exploration phase where you have very short missions. So our isolation is going to be for 10 days. It's going to be in February 2021 in the Swiss Alps. So it's going to be winter. This is also challenging because the access to the tunnel is limited. And well, we have to manage the different risks and measure them to be able to perform the mission correctly. And who? Well, this is probably one of the most exciting part of a mission, the astronauts, and in our case, the analog astronauts, because they're not actually leaving Earth. Well, we selected our astronauts from students all across the world. There were about 200 participants, and the pictures you can see here are the 8 selected for the mission. And they are going through an intense training to be ready for the isolation period in February. And by the way, we decided to call them the Genesis crew, so as the very first crew of Asclepios. When I'm talking about training, there are different parts in an astronaut training. So we try to be as close as what could be done at ESA or NASA. We have an extreme training, diving under the ice, for instance, and safety and health training, because when you're up in an analog mission, if there is something happening, a medical urgency, well, you don't want to break the isolation right away. You can want to see if you are able to do the procedures yourself. This is why we do that kind of training. There's theoretical knowledge such as leadership, how to speak different languages, the history of space exploration, and a bit of politics, geopolitics, which are important. Working as a team, this is a tremendously important, like the most important training, let's say. For that, we organize dress rehearsals, where we put the astronauts in isolation, but not in a very extreme location. We just put them together and see how they behave and if they are ready to be in isolation in an extreme place. And the last but not least, the training to perform the experiments. I will talk about it a bit more afterwards. So here you have a few shots of our astronauts training. So you can see it consists also of sports. So they're doing regular sports, a specific diet. At the bottom, you can see a picture of the dress rehearsal where they were trying to see to gain some skills about mountain climbing. And on the left, our crew commander, Eleanor, which was in a water that was 4 degrees. So it was very, very cold. And I have a quick video that I wanted to show you about one of our training in Valais. So you can take a look at what we did.
Asclepios mission is a do-it-yourself space mission. So we're here in Carnotzet to train our analog astronauts that were selected among 200 international students in order to be up in the mountains to simulate the moon or Mars. We selected them with very specific criteria. They had to be students. This is really the point of our mission. It's to give the opportunity to students to do such a mission. They had to be in STEM, so science, technology, medicine, etc. It's a very international crew. But the most important thing, I think, is we didn't select individuals, we selected a crew. Our mission in April is going to be 7 days in isolation, meaning they will only be able to communicate with mission control, meaning us at PFL. If there is a problem, they need to be able to adapt. So this training is about adapting.
It's good practice being in a stressful situation. That will really get us ready for the mission, to know how to just stay calm and just do what needs to be done.
We're in conditions we're not used to, so in the snow and sleeping in tents, it's getting cool at night. So what do you do? How do you survive? And this is the point of this workshop with Alban here, is to know how to survive.
This morning we sort of discovered that we're going to go diving under the ice, and then at noon we discovered we might go diving under the ice at night. So all these little extra steps are starting to add, and it's I think playing with our excitement a little bit.
Under the ice, it's most likely to be more like the moon gravity, so about 1/6 of Earth gravity. And it's also good because if there's a problem, you can't just go up, meaning you have to follow protocol and procedures exactly like in a real space mission. So this is one of the best activities you can do to prepare for a space mission. And astronauts at ESA, at NASA, is actually what they do. They train in pools in order to be prepared for their real mission.
I think they might have another couple of surprises in store for us, but they try and keep us astronauts a bit in the dark so that we are actually in the stress and don't know what's going on.
How do they react in isolation? How are they going to interact with their crew? Are they able to perform the experiments correctly? And if something goes wrong, are they able to adapt and see the positive and make it happen until the end of the mission?
Ah, du café.
Claude Nicolier, so a Swiss astronaut, said it's a huge benefit for an astronaut application to be able to say, I was in isolation for 7 days, I performed experiment and I fulfilled the mission in the right way.
Okay, so you can see the beautiful mountains of Valais. We try to use them to train our analog astronauts from Switzerland. Then moving on from the training, so our analog astronauts, now they're trained, they're ready, we have the location, we know when we want to go, but what are they actually going to do? We don't want to play dress up, right? We want to have a real contribution to the scientific field. And this is when the science comes into play. So we are collaborating with different laboratories at EPFL, but also all around the world. And some students are working on semester projects, for instance, or just developing on their very own technology that they want to test in our mission. So you have different aspects. You have some extravehicular activities where they go out of the base, like there was on the moon surface. So they're wearing a spacesuit, they can use a little rover, and they can do some research about geology, some agriculture, or different applications. And also inside the base, you have all the human, let's say, science about psychology, risks management, closed loop systems. This is everything that you can test in a mission. And afterwards, of course, being very helpful for our work on Earth. And finally, how? So how do you do all of this? Well, analog astronauts are not by themselves. You have what we call the MCC, Mission Control Center. Basically, if you've seen the Apollo 13 movies, Houston, we have a problem. MCC is the Houston. And we are here during all the mission to make sure everything is working out well, to verify the scientific data, to send it to the different laboratories that are waiting for it to make sure they are safe and healthy throughout the whole mission. And we, of course, plan everything in advance and afterwards. So what then? So you've done your mission. This is a very nice picture of us since the COVID, when we do some meetings at EPFL. You have all these lessons learned of one mission, and you just don't want that to go to waste. You want this to be published in scientific articles. You want to have a big book of lessons learned of space missions for your next one. So you meet with your team and you make sure that everything you got is ready for next year, next mission, and transmitted to the people that will be there next year. And then, well, maybe afterwards you'll be able to go to the moon, but with some Valaisan wine, for instance. A Carnotzet on the moon would be pretty cool, I think. So yeah, let's hope one day we'll get to see that. But for now, we're still waiting to go back. And I just wanted to leave you with a very nice quote, I think, from the Apollo program is that this is a commemoration that we will be here, someone like us, and to some of you out there who are the promise of the future, come back to read it again and to further the exploration and meaning of Apollo. I think it's a beautiful quote, and it really shows that when we went to the moon 50 years ago, it was not as the US or as men rather than women. It was really humankind going there. And when we would go back there, it would be the same. It would be more exciting. It would be you watching, me watching, hopefully, and the future generation will be able to live in a completely different world and hopefully a better world. So yes, usually I like to say at the end of my presentation, there's a famous quote that say, shoot for the moon, you'll land among the stars, from Oscar Wilde. But I like to say that if there's one thing we've learned from the Apollo program is that if you shoot for the moon, you actually land on the moon. So thank you for your attention.
Well, thank you, Chloé. This was a fascinating way to make science fun and something that I'm sure a lot of people would want to pursue. I'll have some questions later, and we'll go on for the next speaker. But yeah, it makes me wonder if he tells more the story about future scientists that want to be astronaut, or if he tells the story about how Valais people have survived in this hard environment because you chose the mountain. So maybe before we go to the next one, just one question: why did you choose Crans-Montana?
Why do we choose Crans-Montana? So analog missions, as I mentioned, there are about 10 of them, and they're usually located in the US or in Arctic or Antarctica, as Julia may mention. And we wanted to have something in Europe. We're in Switzerland. We have these beautiful mountains that could really be moon-like. So this is why we decided to stay in Switzerland. And Crans-Montana, they actually approached us, and we were looking for a lake to do some diving. So we met in the middle.
Oh, wow. That's awesome. And I saw there was coffee there too in the video. Essential to survive. So, but I'm sure there will be a lot of other questions. And again, put your questions in the chat. Or I think you can also raise your hand at the end of the second presentation, or also on Facebook Live. So yeah, now the second presentation is from Julia Schmale. She's an assistant professor at EPFL. She's leading the team of the Extreme Environment Research, a lab at EPFL. Before, she was working at the Paul Scherrer Institute in the lab of atmospheric chemistry. She's an environment engineer by training. She has a PhD from the Max Planck Institute for Chemistry in Germany. And she focused on extreme environment research and has spent time in the Arctic, in sub-Antarctica, and high mountain Asia. And again, I'm not sure if she spent time in the mountains of Valais, because that's also extreme environment. But if you haven't, we will gladly welcome you there. And she's going to share tonight about the Arctic drift experiment called Mosaic. And the goal of Mosaic is an expedition to take a closest look ever at the Arctic, at the epicenter of global warming, and to gain fundamental insights that are key to understand global climate change. So yeah, we're looking forward to hear this second presentation. And Julia, the floor is yours.
Okay, thanks. Thanks very much for the introduction. And I must really say, if I were a student now, I would definitely apply to become an analog astronaut, because it's really fascinating what Chloé showed us. And yeah, you asked me if I spend time in the mountains in Valais. I absolutely do. We can see them from our offices. We're based in Sion, and it's just too tempting. You know, there's always good weather, and sometimes you sit and work all day, and then at night you're really happy to get out. And actually, I do cycle to Crans-Montana, and I think cycled quite a lot of times around the lake that you just showed in your video, Chloé. So it looks familiar. And So I haven't been to space, but I've been to a couple of extreme environments on Earth. And actually, next week, we're going to finish a 1-year-long expedition where my group participated in, which is Mosaic. And this is what I want to talk about a little bit. Just to give you a brief overview, this is a, let's say, scientific style of presentation I'm going to do. So here's an outline. First, I'm just going to motivate a little bit. So why at all are we interested in the Arctic? Why do we actually need to do something like the Mosaic expedition? Then I'm just going to show a couple of data, some first results, so you get a sense for what we're actually doing out there. And then behind the scenes, just a couple of images from life and work on the icebreaker. So first of all, why are we interested in Arctic climate? So on the left side, you can see the sea ice, the summer sea ice. So that's, I don't know if you can see my mouse, but this is the bluish whitish color north of Greenland. And you can also see this orange line, which shows you how far the sea ice reached on average between the 1980s and 2010. And on the 3rd of October, so at the weekend, you see it's a lot less. So we clearly see there is something very fundamental happening in the Arctic. The sea ice is melting away. And then on this other graph, you can actually see how this is this year over time. So here's July, August, September, October, and November. And then the line for 2020 is the blue line. And it shows you how small the sea ice extent was. And for comparison, these gray lines show you, again, the average between the 1980s and 2010. So we're much below this average from a couple of decades ago. And then this green dotted line shows you the worst year ever, which was 2012. And actually, when we were out on the ice in July, we were biting our nails. Is this year going to be even worse than 2012? But luckily, no. So there is a little bit more of sea ice than the worst year, but still we're far below this average from the previous decades. And it's a process that we call a runaway process, so it's really difficult to stop it. I mean, we would have to reduce CO2 emissions or even have negative CO2 emissions, so capture them back from the atmosphere to actually stop this warming. And what is so special about the Arctic? So you see this globe, and the colors should give you an indication of how much is the temperature different between 1960 and 2019. So if you see these reddish colors like all around the Arctic, it means that the temperature difference is between 4 and 4.9 degrees. So this is the amount of warming that happened in these 60 years. And you can also see, if you just compare the colors across the globe, that the Arctic is particularly red. So there we have more warming compared to the average of the globe. And this is something we call accelerated Arctic warming, or also Arctic amplification. So the warming is even worse in the Arctic than anywhere else on this world. Even in Antarctica, it's not that bad. And then if you think about the future, with our global climate models, we can run future scenarios. And here I show you what the Intergovernmental Panel for Climate Change calculated for summer first. So this is the left graph, and there's different scenarios in the different colors, and we don't really know how the humans will behave in the future, so how much CO2 are we going to emit. So the truth will be between one of these different scenarios. And then that means the Arctic will warm between 3 and almost 10 degrees more. But then if you look at what's going to happen in winter, the Arctic is even warming more. So there the scenarios predict a warming between roughly 4 degrees and 13 degrees. So that's a big question for us. Why is the Arctic warming so much more in winter? And so this is what I'm going to talk you through a little bit now. So why do we have this fast Arctic change? What is responsible for this, and what are actually the consequences? So very often people will say, well, the Arctic is warming faster because there is snow and sea ice, and this is going to melt away, and that is a vicious circle, which I can explain with this image a little bit more. So here you see our expedition ship in the middle, and it's moored against this ice flow, but you see there's many melt ponds, and there is this dark ocean water as well. So when the sunlight shines on it, on the dark water can absorb all this heat, and then it can melt the ice. And you melt the ice, then you have even more dark water, and the area in the Arctic gets warmer and warmer, and you have less and less ice. But this is not true for winter, right? There is no sun in winter. So this mechanism just can't happen. So what's then important? Well, there can be other effects, like clouds, for example. And that's my favorite topic because that's something I research. So what happens with the clouds? Well, let's think of it in a really simple way. This is summer, and you have the sun shining, you have the sea ice, and then the sun rays will be reflected by the sea ice because the sea ice is very white, so it's all going back to space. Also, you have lots of clouds in the summertime Arctic, and the clouds are really white too, so they will reflect the sunlight. There's also terrestrial radiation, or radiation from the Earth's surface. And even in the Arctic, at the North Pole, it's a warming radiation that will leave our planet. So if there is no clouds, this warm Earth radiation can just be radiated back to space, and it has a cooling effect. But if you have these clouds, it's actually reflected by the clouds, so they have a warming effect. They are just like a blanket on top of the Arctic sea ice. And now if you think about winter, you take away the sun and all the reflection of the sunlight, and you will just have this warming effect when the clouds are here. So there is more warming compared to the cooling in winter than compared to summer. And of course, now you can play this game with a lot of different suggestions. What could lead to this fast climate change? For example, what is the role of the ocean? What is the role of human emissions? And so on and so forth. And so the scientific community was asking lots of these questions. And then we also want to know, okay, so what happens when the Arctic gets warmer for our lives here? The weather patterns will change, like extreme precipitation, which we just had the last weekend, could be caused by changes in the Arctic. Not this particular event that we had, that was something different, but extreme weather situations like very cold winters that we sometimes have, like 2 weeks that are really cold, that can come from the Arctic. The ecosystems in the Arctic will change. Also, industry will change in the Arctic. Tourism is possible, and so on and so forth. So there's lots of consequences. And now to be able to understand what's going to happen with the Arctic environment in the next couple of years or decades, we came up with the idea of mosaic. So this is what I'm going to talk about now, give you some more insights into the mission itself. On this photo, you can see the ship, Polarstern. It's a German research icebreaker where we were living, where we had our laboratories. You can see this helicopter with which we did some research flights, and there's also some twin otters that came to visit us here. So this is the design of the mission that we came up with, and let's say doing such missions in the Arctic is maybe not as long of a preparatory time as you would need to organize a space mission, but I was involved actually since 2009, so that's 10 years. That's quite a long time to plan for something like this. And the idea that we had is, okay, we have the central observatory, which is the ship. There we have lots of laboratories in the ship. We put our containers on the ship, but then we also want to have neighborhoods on the ice. So we had a remotely operated vehicle city, so the ROV, which goes underwater and can take videos and samples and look at light transmission through the ice. We had Ice City to take ice cores and snow samples. We had Ocean City to take water samples, to go really deep, 4,000 meter deep into the water. We had Met City with balloons, radio sondes and other measurements, and so on and so forth. And of course, logistics were involved to keep this all together and make this possible. And this is how it was planned. So the idea was to start in Tromsø last year in September, which we did. So that worked out really nicely. And then we went to the Russian Arctic here and set up the ship for very detailed studies with all the neighborhoods on the ice. And then we also established like a distributed network around the main ship. So that's 50 kilometers apart, where we had some remotely operating instrumentation for longer term observations. And then we started drifting close to the North Pole. And the idea was that icebreakers would come and go and bring new people and take the previous science crew for some exchanges. And at the same time, we also planned scientific missions with research aircraft. So for the really large scale, because they can fly from Greenland to our ship, they can fly from Europe or Russia and so on and so forth. So we get a really good spatial coverage as well. And then came COVID. So we planned for lots of different things that might happen, but nobody planned for a global pandemic. And so there were a couple of changes to this. So first of all, the idea was to have 6 science teams, and each team would spend roughly 2 months on board. But that actually wasn't possible to do the exchange when COVID hit really hard, so in March and April. And this actually happened to be when I was on the ship. So we were supposed to come back in April, and we got there in February, but then we couldn't be exchanged. So we only came back in June. So we stayed more than twice the time that we were supposed to stay. And I mean, Chloé was talking about that you need to cope with things that you maybe can't foresee. This is something they train for with the analog astronauts. This is nothing we train for when we go as scientists to the extreme environments, but still you need to know this is an expedition. It's not lab work at home, basically. So that changed a little bit. Also, the flight missions couldn't really happen, or just to a very small degree. Because of COVID, there was no air traffic possible. And then the ship was supposed to never leave the ice until the end, which is next week. But actually to exchange, we had to leave the ice and then go back into the ice to be able to exchange ourselves. And this is just to show you how we actually drifted. So from Tromsø, the ship was steaming and then entered the ice, and then you see all these little wiggles here. So this is just how the ice moves. Then we spent a lot of time here. Then we drifted quite far south. Then we had to leave the ice. We went back in. They had to leave the ice again, went back into the North Pole, and now actually they are on their way back. Next week we're going to welcome them back in Bremerhaven in northern Germany. So despite COVID, we could still do this 1 year long mission. It turned out a little bit different, but everybody's super happy with the data that we got. And this is what I wanted to talk about now a little bit. So what is actually the type of science we do there on board? So this is the ship from a drone perspective. This is me on our laboratory container. And this is the container deck, as we call it. And we have lots of different institutions from the US, from Canada, from Great Britain, etc. And we all put our containers there to do atmospheric measurements. And maybe I should say it's a science ship, but there is also a little bar, so you can go down in the evening and have your bar nights. And it wasn't called Carnotzet or anything like that. It was called Zillertal, after a valley in the Austrian Alps, and where you could definitely enjoy a good beer. The wine certainly wasn't as good as it is in Sion, I would say. And there was a swimming pool as well, a fitness room, and so on. So it's really, let's say, in one sense like a hotel, and in the other sense it's like a university or laboratory facility where you can do your research. And so we were really interested in how do the clouds form in the Arctic. And clouds can, of course, only form if there's water vapor in the air, but also they need little nuclei or seeds, which we call aerosol particles. Because otherwise the water cannot condense. The water will never form a droplet if you don't have a tiny seed in it. And so we're researching these seeds. And on the photo, you can see an image from the inside of our container. And next to me is Ivo Beck. He's one of my PhD students who actually spent the dark polar night there. So if he were to go to the Grimsel tunnel, he'd probably already familiar with this dark environment. And so what do we measure? Different aerosol characteristics. So we count them. We want to know how big they are. You can't see them by their eye. So they're like 20 times smaller than the diameter of your hair. So you need special instrumentation, as you can see on the image here. And we also want to know what is their chemical composition. Are they from humans or are they from natural processes? Can they form cloud droplets, and so on and so forth. And we also measure more typical trace gases like CO2, which is the greenhouse gas, or methane, and so on and so forth. And now I don't want to go too much into detail to discuss some data, but I just thought maybe some meteorological data could be interesting to see. So this is for the time that I was on board. So the red trace shows you the wind speed. It's in kilometers per hour, and then the blue line shows you the temperature. So maybe first the temperature. When we arrived in early March or late February, you can see it was actually almost minus 40 degrees. So this is extremely cold, and it was still dark at that time when we were there. So that's actually quite spooky to be out there. And I mean, you probably know this, how the snow sounds when it's really cold and how it sounds different when it's much warmer. So you get this impression there as well. And then in April, the first time, we had 0 degrees Celsius, and you see this transition was so rapid, just in 3 days from minus 30 to 0 degrees Celsius. So that's enormous. And then with the wind also, you see all these peaks here. So in the beginning, when we came, it was really stormy. So every couple of days we had strong storms. And it's quite an adventure to work outside and try to get your data under these conditions. And now I just want to show a couple of pictures and a video to give you an impression how life is out there. And you see 2 journalists here doing the filming, and maybe that's interesting for you. On the 16th of November, there will be a first documentary. It's going to be in German, because it was a German film team, but it's available, or you can get in touch with me for the link. But also the Swiss television will do a documentary, which probably comes out next year. And also the Canadian TV will do it in French. So they might have something in November as well. And yeah, so this is actually our research team. We're a fairly young team, but very motivated and enthusiastic. And despite being relatively young, we have actually tons of experience in Antarctica and the Arctic. And it's a collaboration between Finland and Switzerland. And this is very similar to what Zoe showed us. So we all had to go into cold water and practice a little bit of survival. How would you get out of the ocean water and onto the ice if it happened to you, and so on and so forth. So you do some survival training. And then to actually get to the ship, we had to travel through the dark night. We left northern Norway in the end of January, and then you traveled through darkness. And this was really tricky because this actually had never been done, to travel with a normal diesel engine icebreaker almost to the North Pole. So on this Russian icebreaker, we actually did set a record because, yeah, it just hadn't been done before. And so I brought a little video, and now I'm not sure if the audio works because I didn't have the option to activate it, but it doesn't matter if you hear the sound or not. It will just give you an impression how this was. You see it's completely dark, and you see the water in front of the ship because we were breaking the ice, and it's steaming because the ocean is so much warmer than the air around it. And it was actually tough as a journey because it took 3 times as long as was planned because it was so difficult to get this dense ice. And at some point we were almost thinking we were running out of fuel, so it wasn't even clear whether we're going to get there to do our science. So this was a real, let's say, challenge to be patient, be faithful enough that we can do this actually. And yes, you get an impression how this is when you break the ice and when you're out there in complete darkness. So that was quite a bit of an experience. And then we actually got to the ice and we had to set up some equipment. And there it's super important to do teamwork because none of the science teams will have enough hands or enough people because space on the ship is so limited. So basically you do a lot of tasks that is maybe not your daily business, but so you teach everybody else and then you have lots of helpers, and it's actually a great experience to do all of this together. And here we're setting up a meteorological tower for some measurements. You don't only do science, you also need to maintain your infrastructure. So to run our instrumentation, you need electrical power. So we had all these beautiful orange power lines, and then in the foreground of the picture you see this tripod where we put them on so they wouldn't be snowed on too much, but the ice moves a lot. So there you see this crack, and then the cables are super heavy, so they actually fall just into the water, and then you have lots of tensions on both sides, and on one side will be your instrument, on the other side is the ship, and obviously the ship will win, so you need to run out and see what you can do to alleviate the tension from these power lines. So much of our work, and this is any time of day, if this happens at midnight, you go out at midnight, and luckily in this case we actually had sun. It wasn't dark anymore, and then you do some rescue operations. This crack, which you saw here or which you see here, the next day was like this. So it opened a lot, and then we couldn't get to our mast where we did the measurements. So you need to be inventive. We had kayaks, we had rafts, etc. And so the logistics team would actually help us to get across so we could do our measurements. And I mean, with all this work, scientific work, maintenance work, you also need to have a bit more social time. So we had a couple of soccer games in the logistics area close to the ship. We played water polo and had different types of activities, classical music listening, chess tournaments, you name it. And you make really friends. It's not just colleagues you work with for a couple of weeks and that's it. So we still have WhatsApp groups, we still phone and don't only do science together, but it's really friendships for life that you make there. Yeah, and then you have obviously very beautiful landscapes, and this is part of the fascination. Also for me personally, why I like to be out there, why it's so motivating to do such kind of research. And then there's always these human aspects. You need to plan a lot, you need to adapt a lot, and this just gives you an idea of how we were gathering every evening in our science meeting to, well, discuss science, but also how do we deal with not being able to get off the ship because of COVID-19? How do we deal with these huge cracks in the ice? We can't access our instrumentation. So you just need to be alert and relaxed at the same time to get this all done, what you wanted to do. And sometimes the ice just simply wins. There is not much you can do. In this case, you see the broken hut where we stored a couple of instruments. We saw this coming, so we took out all the instrumentation, but we could not remove the hut on time, and so the ice definitely won in that case. And just to demonstrate a little bit how much the ice moves, there is this animation here. So it's filmed from the research ship. You see another ship there. This is when we actually came. It's still dark. You can see how there is a bit of sunlight, and then you see how more and more daylight comes, and then you see the first time how the ice cracks open. And this is actually very impressive when you see that. So every morning when you wake up, you have a different landscape, which is very different from what we're used to, because when I wake up every morning, the hill or the mountain is still in the same place, the tree is in the same place, but there everything shifts and moves. And it's just a constant change. It's very dynamic, and you need to be highly adaptive to just be able to do what you wanted to do in terms of your measurements. And sometimes it's calmer. Then we had nice weather, but then everything breaks up again, and you need to reinstall things. So it's just a continuous type of work that you need to do to keep such an expedition running. So that's not so easy. And yeah, here you see that there's quite significant movements. And sometimes actually the ship moves as well. So it's standing at an angle, and then you walk uphill when you go to the starboard side, and you walk downhill when you go to the port side. So it's actually quite funny. And yeah, with that, I'd like to thank you for your attention. And if you have questions, I'm really happy to answer them.
Thank you, Julia. This was also a fascinating talk and presentation. And just a reminder, you can ask questions in the chat on the Zoom call or on Facebook. You can send your question in English, German, or French, and we will manage to translate them to the panelists. Yeah, I have just one quick question to Julia. You mentioned water polo. Are you sure? Did I misunderstood? Where do you play water polo in the Arctic? Okay.
So we had a little pool, and basically it was basketball, but in a pool. So the goals were like in basketball. And well, if they had let us, we would have done it.
I was picturing you somewhere like in the midst of the water, in the ice.
Yeah.
Yeah, and yeah, I have just I'm going to open and see the questions are coming in, but just one question about why Sion? Why is Sion important for your lab? Why is that a strategic place for this type of research? And I'm wondering if there's connection with glacier research.
Yeah, absolutely. So, I mean, Sion is in the middle of the Alps, and I mean, you can learn a lot in the Alps that you need to do research at the poles. So the Alps or mountainous regions are also extreme environments. I mean, we discussed how the sea ice melts in the Arctic, but the glaciers melt at a similar rate. So the processes that are happening are very similar. And I mean, if you want, and this is also something, so Switzerland is a member or an observer for the Arctic Council, and the Arctic Council cares a lot about how the Arctic is doing. And to become an observer, you need to bring something to this Arctic Council to help somehow manage the Arctic. So what can Switzerland do? Well, it's very easy. You can say Switzerland is something like a vertical Arctic nation, right? The ice is not horizontal for us, but the ice is really vertical for us. And I think there is no better place to see that than in the central valleys of the Alps. And from Sion, I mean, we see the water reservoirs, we see the glaciers, even from my office window. So it's really the perfect location. And this is also what EPFL had in mind when they designed the center. We have a research center for alpine and polar environments research. It's called Alpol, and it's located in the middle of Sion, just on the southern side of the train station. So I think this is a really great idea to have such a research center in the middle of the Alps, and we can test lots of equipment, we can learn a lot just around the corner here, and then actually be trained when we go really far from Sion.
Nice, thanks. And it seems that we have actually found maybe a new place for Chloé's research. You can go on do your camp and with Julia. It seems that the two worlds could collaborate. But maybe before we comment on this, I'm also interested to see, like, so we hear from both of you, like it's the scientific endeavor, and it's great, it's fascinating. But I have a question more about the human endeavor. Like, what was for both of you the best moment? Maybe just tell us the best moment, the worst moment, and then why. What did you learn about yourself? Because in those extreme environment, I think you can learn a lot about probably human behavior, human psychology. So there's all this humanities aspect to it that I'll be curious to know. And then why? Yeah. So if you could comment with this, maybe we'll start with Chloé.
Okay, nice. I can speak. I just, before answering this question, just wanted to say we are actually collaborating with Julia as of now because of the Carnotzet. Yeah, I actually met Julia during this presentation, and we got in contact, and now we're trying to do things together with the Asclepios project. So
wow,
thank you for.
Look at what happened in the Carnotzet. That's like that's what it is all about.
Yeah,
that's awesome.
So going back to the human contact, on my part, I don't have as much of experience as Julia does, because I didn't do so many things extreme. The most extreme thing I did was the Crans-Montana workshop. So we spent 4 days outside. So we were camping in the snow and doing some diving. I think what's great, well, my feeling was we were a team of 15 people. So the managing team of Asclepios and the analog astronaut is, when you are in a difficult situation, and in our situation at least, it brings out the good in people. So you try to help each other. You try to make sure everyone is feeling okay. So maybe this is getting difficult if the 4 days turn into 4 years, but for us, it was really my feeling. I don't know if you want to add something, Julia, but...
Yeah, sure. I mean, I think it's really true when you're in this, let's say, confined environments where you can't just go hide in the evening, or you go for a run, take your bike, and just be for yourself. I mean, you're always with other people, and so I think being a team and really trying to help each other, make them feel comfortable, is super important. And so for me, the very interesting thing on the ship was when we kind of realized, okay, so we're not going to be picked up on 4 April, and we actually don't know when it's going to happen. I mean, it was never a question if it was going to happen, so that was the easy part. But already this uncertainty of when are we actually going to be able to go home was quite tricky. I mean, those who have families, little kids, they had much more, let's say, stressy experiences than others who do not have such family commitments. But it's very difficult, and so we had lots of team meetings. I was heading the atmosphere team, and with also 15 people, the youngest person being 23 and the oldest person being 68. you get all kinds of different perspectives. And so we were discussing what does everybody need to feel more or less comfortable. And it was really fantastic to see how this difficult situation brought everybody together. And we made really good friends because you get to know the other people. And it's so great if you can help. It's little things. You share something, or I don't know what, and then you make people happy, and you see it immediately. And I mean, this is something that helps you come over more difficult situations. And yeah, so I think this is really something great and very, very close to my heart that I take away from this mission.
Thanks. And to continue a little bit on that subject, Chloé, you mentioned that you selected students that are only from the STEM students, so science, tech students, and no one from the humanities. Like, why is that? If we can't, someone studying the humanities, can they not reach to the moon?
No, of course not. So actually we opened the selection to all students, so it was not just for STEM.
Okay.
It happens that the ones we selected were STEM, but the difficult part, let's say, is for now the space exploration as mainly a scientific purpose. So if you want to send people, you want them to be able to perform experiments. And I mean, if, for instance, imagine Julia wants to do an experiment on the International Space Station, it's going to be years of involvement, like 10 years, a lot of money. So you want to make sure that the person handling the experiment for 10 minutes in space knows what he's doing. So this is why, for now, it's more limiting to STEM people. But this is why I want to emphasize in my presentation, it's not just going up in space, it's seeing the future and maybe sending things to space. We have artists planning on sending artistic creations in the moon. I don't know if you're familiar with SpaceX. Probably you all know Elon Musk and his crazy ideas, sending Tesla, etc. in space. And he has this spaceship called Dear Moon. And for the very first travel to the moon, he wants to say a team of artists, so journalists, photographs, fashion designers, to do the circle the moon and come back to Earth. So it's open for everybody. Just as of now, it's true. It's more for STEM.
Thanks. And then to carry on this this topic about the kind of the place of the human in this research endeavor, we talked a lot about human exploration and that in what you guys do, you both have to be in the extreme environment. But I'm wondering in the future, to explore the future, what could be the relation with drones or space probes or robots? In short, with the digital revolution or automation, can this disrupt your work? Or is it, maybe even like now being a little bit stuck with COVID and trying to still do the research, like how do you see the future to use technology even further, and then what is the place and the role of the scientist in what you do?
Yeah, I mean, absolutely. That's a really great question. To put it very simply, I mean, as scientists, we love data. So the more data we get, the better, the happier we're going to be. And so if I don't have to prepare for 10 years to get such a mission through and then work really hard for 1 year, having people on the ship or being myself on the ship, but if I could just place little instruments, maybe just fly over with a plane, drop them, they stay there, and then they send me the data and I get similar information or even better information than putting a heavy container on the ship, that would be brilliant. Then we could just transfer the data via internet, and then we can work much easier on the data analysis from the laboratory. So that would be the great aspect about this. But the one, maybe thought of caution is when you're out there in the extreme environment, you're in the environment that you're researching. And by experiencing the environment and seeing things that might not even seem very significant to you at that time, But when you look at the data and you interpret the data, you actually have much better ideas of what the data tell you when you have been in such an environment. So if we were just to send instrumentation there or use satellite data and never go to the Arctic and never experience how such a crack opens and how the water vapor then comes into the atmosphere, we might not be able to recognize this from the data. So I think this human recognition is hugely important. And even though we will, I'm very confident we will soon have the means of collecting data in this way, also in the very remote places, we still need to go to be able to interpret what we get on our desks.
Yeah, I completely agree with Julia. It's actually a big debate in the space area. Why do we want to send people to the moon or Mars when we can send probes for less amount of money? But the probe, first of all, if it has a problem, if for instance it's stuck, it's going to remain stuck anyways. If you have someone, it can be more adaptive depending on the situation. And the feeling of being up there and telling the story when you go back to Earth. I don't know if you've ever heard an astronaut speaking about what it was like to be in space. But I know for me, it was the turning point of knowing why I wanted to work in the space area. So not only doing and collecting the data, but as Julia mentioned, experiencing it and telling the story of how it is. That changes everything for me.
Thanks. And Chloé, you also mentioned so it's you work in a do-it-yourself space mission, and you say like a lot of people can get involved, and I'm a little bit curious because I'm like, hey, maybe I'd like to get involved into this type of research, and I'm wondering if you guys are developing more like citizen science project. And I mean, that could also be a question to Julia. Like if we go on, we know that citizen science is a big movement now, and like citizens are getting excited about research project, and they'll be like, hey, how can I contribute as a citizen to both of your projects? And the ultimate question to Chloé is like, are you going to go to space?
So those are many different questions. To begin with the last one, I hope so. That would be a big dream, and going up to the moon or to space would be the ultimate thing for me.
And when you do, make sure to connect with us, and we'll do another
Carnotzet.
I cannot say live.
You give me a bottle from Valais so I can drink it on the moon.
Perfect.
Yes. For just to answer very quickly, unfortunately, it depends, of course, on your skills, but also on the timing. For now, if you want to become an astronaut as a Swiss citizen or French citizen, in my case, you have to go through the selection of European Space Agency that opens basically every 15 years. So you have to be where you're in the best place in terms of age, experiences, etc. So I definitely apply when it comes, and we'll see if I can get in. And to answer your first question about citizen science, yes. So I think what's interesting in the space area, and especially with the rise of companies, private companies such as SpaceX or Boeing or Virgin, is you have much more different fields which are interesting, such as the legal, like what are going to be the laws in space, communication, but also design, etc. So in the Asclepios mission, we try to remain a student organization. So we welcome students, whatever the field, all around the world. If you are not a student anymore, there are many other projects I'm sure you can get involved in.
Thanks. And how about you, Julia? Any ways citizen could get involved?
Yeah, absolutely. So we actually have a project in Alaska, and there the big challenge in the Arctic part is that in winter it's a very polluted place. And that's something also that connects maybe Valais with some valleys in the Arctic. From here, in winter you have this inversion layers, you have this air that's really trapped close to the surface, and all the air pollution will accumulate. in this inversion layer. And above, when you climb up the mountain a little bit, you have nice blue skies, you have fresh air, etc. And this is the very same that happens in many places in the Arctic. And there, sometimes in the villages, they burn whatever they have, and it's terrible air pollution in a remote place. And so we work with them. We have little sensors that can collect data on air pollution, and it's called Purple Sense. And then we get better data, and we can help identify what are the sources, and then we can do projects with the local communities, thinking about, okay, how can you improve this? What else could you use for heating? Maybe can you stop your car and not have it run, and things like that. So there's actually science with citizens for citizens. And there's also lots of ecological experiments where lots of people helped, and you don't need to be a scientist to be that. It's called the tea bag experiment. So all around the Arctic, people were asked to just take a tea bag and dig it into the soil. Then have the coordinates, and then scientists would go later, a year later, and dig it out and see how much is the degradation to understand how biologically active it is the soil. And so that's wonderful. It's a super simple experiment. Everybody can take part, and it gives so much rich data from very different ecosystems all around the Arctic. And yeah, we're always very happy to collaborate.
This is great. So this is a call to people listening to be involved in such research. And so we'll arrive shortly to the end of the Carnotzet. So unless there's other questions, make sure to write them in the chat on Zoom or Facebook, or you can raise your hand. We can bring you to the screen. If not, since you mentioned both that you love data, I have some very, very important data to share with you from a very important poll we just did. We asked people, would you rather go to space or Arctic? And 53% replied both. 18 would rather go to space, 29 to the Arctic, and nobody said none. So everybody wants to go to one or the other. So that's some very good news. Maybe space tourism. I don't know if it's a good thing or not, but it seems like people want to go. So yeah, that's exciting. So it means they can at least be involved in a citizen science project. If I doubt I'll be able to go to the moon, but I will be glad to see Chloé there, and I can say, hey, I know someone. Yeah, so this is it for me, and this is it for the question. I'd like to thank you both again for this. I think this was yeah, very inspiring and fascinating talks. I think this is also great to just inspire people to go into to science and research. And yeah, so it's a very encouraging evening. And I'd like to bring it back, give the mic back to Alexandre.
Thank you, Johann, and thank you, Julia and Chloé, and everyone who took part in setting up this Carnotzet. I will keep in mind that you say that the mountains are a good place to do research and getting ready for Arctic and space exploration. So we are really excited to be living in this country. I hope that we will be also able to stay in touch and follow up on your scientific adventures. For the people who want more Carnotzet, there are two next dates. The 29th October, we'll talk about big data and artificial intelligence in German this time. Big data und KI, Freund oder Feind. And on November the 1st, we'll go to Mars this time. So thank you, everyone, and cheers, and see you next time. Bye-bye.
Thank you.
Bye. Thank you very much. It was really cool.